Knock knock, who's there? 4.3, solving systems by elimination. Alright, here we go. Last method of solving a system of equations. So we have graphing, we did substitution, and now we're doing elimination. So we're going to break this down into 4 steps that we can follow. Alright, the first step, and again, just like with substitution, these steps might not make a whole lot of sense for you until you've used them, but I'm going to give them to you right now anyway. So the first step is to multiply. And what we want to do is we want to multiply either one equation or both equations to try and make coefficients of like variables match. And again, my awesome handwriting. So multiply to make coefficients match. After we have coefficients match, we want to add or subtract one equation from the other. And what that's going to do is eliminate. So add or subtract to eliminate. Once we have something eliminated, then we solve that new equation. And then plug that new value back in. Now again, I know that some of this, most of this, all of this probably makes no sense just looking at the steps and not really knowing how they work. So let's see it in context with this first example. My first step says to multiply to make coefficients match. Well, what am I looking for? I'm looking at the x's, the coefficients of the x's, and the coefficients of the y's. I want them to be the same thing. They don't both have to be. I don't have to have the coefficients the same for both x and for y, but I want the x's to match up, or I want the y's to match up. They don't both have to. It just so happens in this case that the coefficient for x here is 1, the coefficient for x here is 1, so they match. The coefficient for y here is positive 3, coefficient for y here is negative 3. They also match. So I have a choice. I could add or I could subtract the equations from each other in step 2 in order to eliminate one of those variables. So what I'm going to do, for the simplicity of this one, I'm going to add the equations together. I have matching coefficients, so I move on to step 2. Step 1 is done, and I add the equations together to eliminate. Now what happens? When I add, I go x plus x is 2x, 3y minus or plus negative 3y gets me 0 y's, and that equals negative 2 plus 16, which is 14. So what do I have left? I essentially have an equation that says 2x equals 14 because the y's are now quote unquote eliminated. So 2x equals 14, I divide by 2, x equals 7. Am I done? No, I am not done. I have done step 2, I've added or subtracted. I have done step 3, solve the new equation. But I still have step 4, plug back in. I need to take this x value and come back up here, plug it into the equation to get my y value. We know that the solution to a system is a coordinate point. Just getting this is not done. So I plug it back in. X, or 7, plus 3y equals negative 2. I subtract 7. 3y equals negative 9. I divide by 3. And y equals negative 3. Now I'm done. I have a coordinate point 7 comma negative 3, which is my solution to this system of equations. It is the one point where these two equations cross and intersect. It is the one coordinate point that they share in common. Now let's look at a harder example. Okay, in our last one, my coefficients were already set up for me. It was nice and easy. Let's look at one where that's not the case. Okay, in this one, I do have to go to step 1 and multiply. Multiply to make coefficients match. Now, when I multiply something, I have to multiply the entire equation. So I'm looking at my x's and I see a 2 and a 6. Okay, it's possible I could multiply the bottom by 3 to make them both 6's. When I look at the y's, I have a 5 and a 4. I could multiply the top by 4 to make that a 20, and the bottom by 5 to make that 20, and the y's would match up. But I think my plan with the x's is simpler. So I'm just going to multiply the bottom by 3 to change these x's so that they match. That's what I'm looking for. So when I multiply everything. So this is going to become negative 6x, exactly what I wanted, but I also have to multiply the y, negative 12y. And I also have to multiply the 14, and that's going to become 42. Now, that equation is no longer involved. Now when I add and subtract, I use this new equation that I just made. It's just a multiple of the original. So I have a negative 6 and a negative 6. What am I going to do in order to make them disappear? I subtract. Negative 6 minus negative 6, yes, makes those eliminate. Makes me get 0x. 5y minus negative 12y, well, that's double negative. So that's 5 minus negative 12. It's just like adding, so that's plus 17y. And then 25 minus 42 gets me negative 17. I added or subtracted, and I solved that. Now I have to solve this new equation. I divide by 17 and divide by 17 to get y equals negative 1. Solve a new equation, done. Now, one last step is plugging it back in. I go back to my original equation, negative 6x plus 5y, and y I just found out was negative 1, equals 25. Whew, now I gotta solve negative 6x. Multiply these two things together, I get negative 5 equals 25. Then, I just have two more steps to do. Add 5 on both sides. Oops. Getting ahead of myself, putting equal signs in places. Plus 5. So that means negative 6x equals 30. I divide by negative 6 and divide by negative 6. And I get that x is equal to negative 5. And now I am done. I have the coordinate point. Negative 5, comma, negative 1. The one place where these two original equations met and they intersected. The one coordinate point that they both share that makes both of their equations true. Alright, so that is solving by elimination. Good luck with the assigned problems. Write down any questions that you have for me, and we will talk about them in class. I will see you all later.